All right, so let's try this again. All right, so we are doing a review of some Blase and Blee for our test coming up. And the first thing I want to do is hit the sections that people were saying that they were kind of unfamiliar with. So that would be lessons 5, lesson 6, and lesson 7. Well, those are represented in questions 6, 7, and 9. So let's just jump right in and let's start with lesson 5. Lesson 5, there we go. So I'm going to make this bigger and let's look at pretty much the gist of lesson 5. So we're going to do problem 6A. All right, 6A. Oh, didn't mean to get this part. Oh man. Okay, so we're doing 6A. Try this one more time. Yeah. Bam. Okay. So use the process outlined in the lesson to approximate the number 5 to the radical 7th power. Use the approximation. Radical 7 is 2.6457131. Find a sequence of 7 intervals that contain 5 to the radical 7 power whose endpoints get successively closer to 5 to the radical 7 power. Write your intervals in the form of 5 to the r power is less than 5 to the radical 7th power, which is less than 5 to the s, for rational numbers r and s. Well, let's talk about something a little more basic so we can get the gist of the idea. So let's pick a number. How about 6? Okay? And we're going to put 6 in an interval where it's got 2 endpoints. So let's think about, so you can really get good visualization. So let's think about the number 6 on the number line. And let's think of 2 numbers that 6 is between, right? Well, in this case, we're going to make it a little bit closer. And we're going to say 4 and 8. It's going to be 4 and 8. So what does that mean? Well, 2 to the second power and 2 to the third power. That's 4. That's 8. All right. So anyway, I got my 4 and my 8 that are that have 6 between them, right? And so now, what does it mean when it says find a sequence? So sequence of 7 intervals. Here's my first interval. Okay, that contain, my 6, whose endpoints get successively closer. So what the heck does that mean? Well, successively closer means every time I finish one interval, the next time I'm going to have an interval that's closer to it. So for instance, I'm going to say, how about right here, 4.2 and 7.8. That's closer. I mean, not much closer, but so my numbers are going to be 4.2 is less than 6, and 6 is less than 7.8. So that's my second interval. I got 5 more to go. So how about the next one? I'm going to say 4.49, and I'm going to say 7.51. So this is my third interval, and I'm going to say 4.49 is less than 6, and 6 is less than 7.51. Now, honestly, I'm picking arbitrary numbers just so I can get the point across. Okay, but we're with this process, we're going to have something a bit more solid as far as the process is concerned. So just bear with me. I'll do one more and then we'll call it so we can move on to the real stuff. So, what about, let's say we're going to move here. So that's 4 point, excuse me, 9 9 1. So this is my fourth interval. That's 4.991 is less than 6, which has, let's say, 7.112. So I want you to see what's happening here. I started with one number, then I got two numbers, then I got three numbers, and now I got four numbers. So my fifth interval, I'm just going to make this quick. I'm just going to say 5 is less than 6, and 6 is less than 7, and call it. Now, that's not how this is going to work exactly. This fifth interval would have, this has had one, one digit, two digits, three digits, four digits. So my fifth interval would have 5 digits. Okay. So I guess we might as well just be thorough. Fine. Yes, yes, I know we're doing it. So I'm going to say this is 4. Well, no, let's not say 4. Let's say 5. So let's say we're going to say 5.799 4. Fine, let's say 7.999. And so here I'm going to say 7.0009. Again, I'm picking arbitrary numbers, just some numbers that are kind of at random. But this process is going to be a lot sturdier. So I hope you see what's going on here. I got this number, and then I just started increasing. I had 5 success. Oh, I'm sorry. This thing says 7 intervals. Well, you know what? I'm only going 5. So nope. So I went 5 intervals, and each time the interval got a little bit closer to what we were looking at. You got what I'm saying? It got a little bit closer, just a little bit closer. Okay. All right. So now let's copy this, and then we're going to do the deal. Okay. So here we are again. Yeah, we're going blue now. So we're using the process outlined in this. And find the sequence 7 times, whatever. Intervals, blah, blah, blah. Come on, you're making me look bad here. Intervals, blah, blah, blah. There we go. All right, and let's pick purple or bold this time. Okay, so what do I got? So my number is 5 to the radical 7th power. Now you may wonder why they pick radicals, because radicals have, if you get a radical that doesn't go to a whole number, it's a really long string of numbers that seemingly are random. So I'm going to write this down here too. I'm going to say radical 7 is approximately, that's what that squiggly equal sign means. It means it's close to, that is a good guess, 2.6457531. Okay, so let's start with our first interval. Well, let me make sure you understand what's going on here. So for my first interval, I'm looking at, let's say the first two numbers, 2.6. That is what this radical 7 represents. So this first one is 5 to the 2.6 power. I need to think of two powers of 5 that are going to contain 5 to the 2.6. Well, that's easy. 5 to the second power and 5 to the third power. See, 2.6 is between 2 and 3. Bada boom, bada bing, first interval done. So now that was 2.6 that I chose. So now I'm going to look at 5 to the radical 7, and let's say we're looking at 2.64 as a number. So that means I'm looking at the power of 5 or 5 to the power of 2.64. So I need to think of what two numbers that can be in between. So I'm going to have 5 to the 2.6 power. You can kind of think of it like 2.60 if you want. So, right? Because this number is 2.64. So then what does that mean this number is? Well, that's going to be 5 to the 2.65. I just went one digit over what this number was representing. And see, I've already gotten closer. And that's my second interval. I got 7 to do. So on to the third, right? So now let's go to another number. So that's going to be 2.645. So that's going to be the power, or that's going to be 5 to the power of 2.645. So I need to find two numbers that are going to contain that. So that's 5 to the radical 7th power. Notice I'm drawing these decimals over here and not here because that's not what they want me to do. They don't want me to put that stuff. This stuff over here, that is for your benefit so you can understand what's going on. This is what the assignment requires. So I'm going to have this. And so now, as I said up here, we're writing it in 5 to the r power is less than 5 to the radical 7 power, which is less than 5 to the s power. So let's keep going. So if I'm trying to find two numbers that 2.645 are in between, I'm going to say 5 to the 2.64 power. And remember what I did with the little temporary, the little 6 that we were doing in finding interval. Look how these digits are following the same pattern. 2, right? That's one digit, then that's two digits, then that's three digits. Now it's a little misleading over here, so let's just focus on this side. So one digit, two digits, three digits. So then this is 2.645. So then that means this is going to be 5 to the 2.646. All right, so that's my third interval. Next, now I'm going to go to the 7. So 2.6457. 2.6457. That is 5 to the 2.6457 power. So that's 5 to the radical 7 power. This first one is going to equal 5 to the 2.645 power. So this is going to represent 2.6457. So then what's going to be here? It's going to be 5 to the 2.6458. So see, 1, 2, 3, 4. So what's next? That was the fourth interval. Got 3 more to go. 5 to the radical 7th. Whoa, not 3, 7. The radical 7. So what's before it? Well, this number is 2.64575. So this number needs to be 5 to the 2.6457 power. And then this number, 5 to the radical 7 power, is 2.64575. So then what does this have to be? One number over that, so that's 2.64576. Okay, 1, 2, 3, 4, 5. So that's my fifth interval. That's 5 to the 2.64575 power. So we go to the next number, right? That's 1. So we're looking at 2.6457551. So that's what my 5 to the radical 7 power represents. So for my next interval, it's going to be 5 to the 2.6457 5 power. And then the 2.645751 power is represented by that square root of 7. And so then what do I have out here? I just add 1 to this increment. So 5 to the 2.645752 power. That's my sixth interval. That was 5 to the 2.645751 power. And then finally, dun, da, 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 we're looking at the 7th. So that's going to go all the way to 3. So I'm looking at 2.645751 So I'm looking at the 5th, or 5 to the 2.645751 power. So what's before that? Well, that's 5 to the 2.645751 power. So that's 1, and then this one is 1, 3, right? 1. And so then what is this one? This is 5 to the 2.645752. And that is 7 intervals, right? 1, 2, 3, 4, 5, 6, 7. Bada boom, bada bing. Right? So that's how we do that. So let's get this back out the way. So let's do this really quick. Okay. So radical 10 is approximately 3.1622777. Find a sequence of 5 intervals, yeah, I'm not doing a 7, that contain 3 to the radical 10 power whose endpoints get successively closer to 3 to the radical 10 power. Right in the 3 to the a power is less than 3 to the 10th power, or excuse me, 3 to the radical 10th power is less than 3 to the b power. So I'm going to start with 3 to the radical 10 power. And what would be a power of 3 that is less than? Well, I start with 3, 1. So 3.1. So my A is 3 and my B is 4. That is one digit that I worked with. One digit, right? So now I'm going to do the same thing, only now I'm going to work with 2 digits. So I got that. I'm going to say 3 to the 3.1 power. And somebody's calling me. I'll call them back. So see, I'm on 2 digits. If you think about it like this radical 10 is right now is representing 3.16. So I need to think of something that's before it. Well, 3.10. So like $3.10 is less than $3.16, but what's more than it? Well, $3.20. You see? $3.20. So now I've got 2 digits. So now I need to have 3 to the radical 10 again. And now I need to have 3 digits. So I have 3 to the 3.16 power. So then this is 3.162. So then that means this is 3.163. And then next, I'm going to have 3 to the radical 10 power. Less than and less than. And so I'm going to go to the next decimal place. So this is going to be 3 to the 3.162 power, because this one is 3.1622. So then what is this one over here? 3 to the 3.162 power. Ouch. And then finally, 3 to the radical 10. I need to think of how many decimal places. I'm gonna have 4 decimal places because this one has 4 digits, so it's gonna have 5 digits. So the number that I'm representing now is the 3.1622. So that's my 5 digits, right? 3.1622. So then that means this number is going to be 3 to the power of 3.1622. This is going to be 3.16227. So then this number over here is going to be 3.16228. And that's my 5 intervals for that. Yay. It's not really that bad. I know it looks weird, but it's a simple pattern if you just follow it. And what I'm probably going to do, because there's so many folks that are kind of having issues with this, I might make this one say an extra credit problem. All right. So let's go to lesson 6 because we're taking a long scenic route to get this thing done. Okay, lesson 6 talked about the rate of change, the average rate of change. Okay, so we are going to do the average rate of change. Given a function f whose domain contains the interval of real numbers a to b, right? What I can do is I can use this formula right here. If I have an interval, like an interval right there, right? I have an interval, and I plug that interval into my function. Well, my function is x squared plus 1, right? That's my f of x equals. That does not look like equals. Okay. So equals x squared plus 1. So my interval is 3 to 5. Well, notice that means that my 3 is my A and 5 is my B. So I'm going to start with B. So I need to have f of 5 minus f of 3 divided by 5 minus 3. So what's f of 5? Well, let's think. F of 5 is this function with 5 replacing x. So that's going to be 5 to the second power plus 1. Now, before you tell me that's 11, let's have a chat, okay? 5 to the second power. When your numbers are not basically the same size, okay, it's an exponent. See, 5 times 5 is 25. 5 to the second power represents 5 times 5, which again is 25, right? So f of 5 with this function, x to the second power plus 1, I'm going to plug into 5 wherever an x is, and now I'm going to have 5 to the second power plus 1. Well, 5 to the second power is 25, plus 1 is 26. So then what about f of 3? So f of 3, I plug 3 in here. So that's 3 to the second power plus 1. So 3 to the second power, that's 9 plus 1, that's 10. So I've got 10. So let's write that up here. So I have f of 5 minus f of 3 divided by 5 minus 3. So that goes to f of 5 is 26 minus f of 3, which is 10, and then that's all divided by 5 minus 3, or 2. Well, 26 minus 10 is 16, and then obviously 2 just stays 2. So now I have 16 divided by 2, because that's what a fraction or a ratio is. It's just a division problem. So 16 divided by 2, that's 8, and 8 is my answer. So it's just a matter of using this formula, right? Taking this formula, taking your interval, so they gave us 3 to 5, so we plugged in 5, and then we subtracted 3, plugging in 3 from it, so 26 minus 10, and then we divided it by the difference of the interval, so 5 minus 3. And there you go. That's 2 lessons down, 1 big bad mamma jamma to go. All right, excuse me, I had to take a sweet tart break. So now we're looking at number 7, okay? I need number 7. Yep, there we go. All right, let's make this a little bigger so you can see what's going on with it. Okay, so let's just start with this first problem. It says work with a partner, but you don't get a partner, you just get me. So I have 2, I'm making it bigger so you can see it. 2 to the x power equals 2 to the 3 power. Well, because those bases are the same, the only thing I have to work with is the exponents. So x and 3. So 2 to the x power needs to equal 2 to the 3 power. That means x equals 3. I mean, simple, right? It looks like this problem got stripped right from the work. So let's work on that one. Let's just jump right in. Well, before we jump right in, let me make some correlations and then we'll jump right in. Okay, so let's start with B. If I look at B, my bases are the same. So what does that mean? Well, if I think of 5 to the 3x plus 4 power and say it's equal to 5 to the x minus 2 power, what does that mean? Well, the bases are the same. So if I'm saying those are equal, that means this needs to equal that in order for that to be the same. So I have 3x plus 4 equals x minus 2. And that's my equation. That is a simple equation where I get the x's to one side and the numbers to the other. So 3x plus 4 equals x minus 2. So I'm going to subtract x from both sides. So that's going to give me 2x plus 4 equals a negative 2. Then I'm going to subtract, sorry, not 4, not 2. We're going to subtract 4 from both sides. So minus 4 from this side, minus 4 from this side. And I end up, that's not a 9, that's a 4. I end up getting 2x equals negative, whoa, too much. Okay, so let's move this over so you can see it. So that ends up being 2x equals negative 6. Because these cancel off, and I got 2x on the left equals negative 2 minus 4, that's negative 6. Well, again, this is an easy problem, so I just divide by 2, and I get x equals negative 3. Boom, I'm done. So see, that's how I would do this problem. But see, oh no, Fer, what am I going to do? The bases aren't the same. Oh no. Well, like I said, that's stripped right out of this. So let's do that problem. 2 to the x power equals 16. Well, see, the thing about 16, right? The thing about 16 is that 16 is 2 to the fourth power. So then that means I could just change it. So I got 2 to the x equals 2 to the fourth power. Now I'm back to where I started from. You know, the same problem here. So x equals 4. Boom, I'm done. All right, so we got the last problem. So I'm just going to move away a little bit. I think I might do that problem just for giggles, but let's do this problem first. So I got 3 to the 2x power times 3 to the negative 8 power equals 1. Oh no, Vert, what am I going to do? This isn't 3. The bases aren't all the same. Well, here's the rub to make it easy on you. 0. Anything to the 0 power is 1, which includes 3 to the 0 power. Now all of my bases are the same. So now these two things are being multiplied, right? So that means I add the exponents. So now what I'm going to do is I'm going to get rid of the 3. I'm just going to say 2x minus 8 equals 0. Now I said add, but this is a positive 2x and that's a negative 8. So when you add a positive and a negative, it's going to be 2x plus a negative 8. I just took the plus out of there and just said 2x minus 8. So now I'm going to solve this problem the same way we solved the other problems. I got 2x minus 8 equals 0, so I'm going to add 8 to both sides. And I'm going to get 2x equals 8. Then I'm going to divide by 2 on both sides and get x equals 4, and I'm done. X equals 4. And that's how you do those 3 things that you were a little unsure about. So I'm going to stop this video now, and happy trails to you.